Let's learn more about how effect works by building a tiny itty-bitty toy version of effect, and we'll call it Toyffect. Let's scope it out. Effect is a pretty vast toolkit. So what is the minimal API service area that we want to recreate? Well, I don't think we need to take on pipes and dual functions or layers or even error recovery, at least for now. But I think we should implement something similar to effect gen, so the generator function-based means of composing effects. And I'd also like us to implement the type-safe dependency injection. So our effect type, or our Toyffect type, will have two type parameters. One will be for the successful result, and one will be for the requirements, which need to be provided before the effect can be executed. And by the end of this video, we're going to have a functioning toy effect library. So the link should be in the description. Let's roll. So to start out with, we have basic project boilerplate here. This is a monorepo. It has two packages. One is the Toyffect package, where we'll actually implement Toyffect, and one is an examples package, where we will import and make use of Toyffect. The package JSON of Toyffect currently reflects that there's an index. So let's create that right now, index.ts. And this is just going to be a barrel file. So let's think about the first re-export. The first thing we're going to re-export is our result namespace, which we're going to make momentarily. We'll create a new file, result.ts. So we'll make our result type, export type result. This will be generic over the successful value. In the case that we have succeeded, the value is A, and in the case that it failed, the exception is unknown. And that should really cover it for our result type. Let's add an instruction.ts. And in here, we're going to have the values that are yielded, not yield starred, that communicate to the generator interpreter how to proceed. So let's mock this out. We're going to have export type instruction equals, and the first instruction should really be here's a unit of computation, execute it type instruction. So this will be instruction.promise, and we give it the underscore because we wouldn't want it to clash with the global promise. We're also going to export declare namespace instruction, and in here we're going to export interface promise. This will have the A type, and read-only tag is going to be, and then read-only f is going to be the function that gives us the promise of A. And so this is going to be kind of like effect.promise, where we would give it some kind of a promise in here. And let's get rid of that. Maybe one other thing that we'll want to do is pass in an abort signal. And this way, we're able to potentially interrupt promise execution if the current fiber fails. We're also going to want to add a default type argument of any. And this way, we'll be able to refer to the widest promise instruction. The next instruction that we're going to want to create is the require instruction. And when we yield this instruction, it's going to communicate the requirement in the type system. And at runtime, it's going to say, hey, I need this requirement. Please give it to me. So down here, we will export interface require with R. We'll also give this a default of any. Read-only tag is require. And then read-only tag is R. Now, I know this is a little confusing given that we have tag and underscore tag, but in the case of requirements, the effect API is context.tag. You create a tag. So I do think this is probably the correct name. The next instruction that we're going to want to make is for executing toyffect.gen. So this will be instruction.gen. We will go down here and export interface gen, and y extends. We will constrain it to an instruction is instruction as the default. Read-only tag of gen, read-only f, so the generator function equals a nullary function that returns a generator of y and any. And the reason that this type parameter is called y is because it's the yield. And then the final instruction that we're going to want to make is for forking. So taking a Toyffect and creating new toy fiber. So we'll come back down here, we'll export interface fork, the successful value is any, and the requirements, we'll get to this soon. For now, we'll just set it as any, and we'll give it a tag of fork and a read-only Toyffect. And in order to complete this interface, we're going to need to create the Toyffect type. So really, there are a few missing pieces here that we can't quite get to yet, but we will. For now, we're just going to comment this out. And then up here, we're going to comment out that member. Next up, let's create a context.ts. So the first thing we're going to do is create an interface tag to represent the requirement. So the value, which we are defaulting to any here, we're just going to track at the type level. So this interface isn't actually going to have much runtime significance. This is just for us to constrain the representation of the tag so that we can extract from it the read-only value to which it evaluates when yielded. Now we need to create our tag function. So this can shadow the interface, export const tag equals, and the tag is going to take in first the given key, and then it returns a thing. And this thing is going to be just like the effect context tag. So it's going to be another function that takes in two type parameters, a reference to the thing that extends the call of this expression and the value or the runtime requirement that this tag represents. And then it returns a class. So in practice, we should be able to say class bar extends tag, give it a name, give it itself, give it a value, call it, and there we go. We have our tag. But we still have a little more work to do. So within here, we need the statics of the resulting class to implement this. So within here, we'll say declare static v is v, and now bar is structurally aligned with tag. We also want to say read-only key equals key. The other thing we need to do is implement symbol.iterator so that we can yield bar within a toyffect.gen. So static symbol.iterator, and this is going to give us a generator of a yield of the require instruction. So let's go up here, import from instruction, go back down here, instruction.require C. So that's the value that we want it to give us. So later on, we're going to do some type mapping and extract any of the required constructors in order to create the presentable Toyffect type. And then the result of yielding the tag should be the given value. Let's go up here and import this as type. We'll go back down here and we're going to yield the instruction. So yield, and here we should get some completions. We do indeed. And the tag is going to be this. And that's because this is a constructor, so bar, for instance, which ultimately serves as our reference to the requirement at runtime. We're getting a type error here, but we can ignore it. The compiler doesn't really understand what we're trying to accomplish. So we'll override this as never. Some people like to say as any. I like never. It's a little more rebellious. And the last thing that we're going to want to do is return this, because when we ultimately call next on this generator, we are going to pass in v. And so this yield expression should evaluate to v, which we should then return. And that's how we're actually going to get the requirement into the currently executing generator. Let's go ahead and delete this. And voila, we have context tag. Next, we're going to create our Toyffect.ts. And in here, we're going to export interface Toyffect with a. The requirements, it's going to extend context.tag. So we're going to want to bring in star as context from context. And we will default this to never. We're going to have a run method directly available on the Toyffect. And this needs to be a Toyffect of a and never. Never because we cannot run it if there are requirements that have not been provided. And finally, we're going to get a promise of result of A. We can bring in result. Now we need to deal with requirements. So let's create a member provide. And the way we provide things is by specifying the tag for which we want to provide. So f extends context.tag. Tag is f, and then the runtime value corresponding to that tag. So instance is f v, and this should give us a Toyffect with the same successful return type. And then the new requirements should exclude the instance type of f. However, you see we're actually getting this error underneath f, and that's because we didn't constrain it to be a constructor type. But we know it's going to be. So what we can do is we can extract from f a constructor type. And that's a nice little trick. So the compiler leaves us alone. Maybe let's make that read-only. And one other thing that we're going to need is to track the requirements that we do provide. So we're going to have a read-only provided, which is going to be an array of entries where the key is the context tag and then the requirement, which is unknown. Next, let's export declare namespace Toyffect. And we're just going to create a few utilities. So export type any, and this will be a Toyffect in which we widen the requirement type. I know it's not super important, but it might make our lives a little easier. We're also going to create a utility A, which will take in any Toyffect, and from it, we're going to infer the successful return type. And then we're going to want to do something similar for the requirements. Only over here, we'll unwrap from Toyffect. We don't care about the A value, and we will rename this to R. And so these utilities should go a long way as we do some type level mapping. Now we should be able to go to instruction and finish declaring our for instruction. So up here, we're going to import star as context from context, and we're going to import star as Toyffect from Toyffect. We will uncomment this. We'll go down to our interface, uncomment that. And now let's go ahead and extend context.tag and have it default to context.tag. And then the Toyffect is going to be Toyffect.Toyffect with A and R. And that'll cover it. So we have the 4 instructions that we'll need to handle within the loop that interprets our generators. Now I think we're actually ready to write that interpreter. And I'm loosely calling this a fiber. Now again, this is a very basic implementation, and the effect implementation is a lot more sophisticated to say the least, but I think we'll be able to go over some of the core ideas. So fiber.ts, and we will import star as context from context. And then we will export a fiber context type, which is a map from a context tag to some unknown value that the tag represents. And now we will export class fiber. Here we do want to represent the success type of the fiber, but we actually don't need to represent the requirements. Those will be communicated solely through Toyffects. And we'll default this to any so that we can later reference fiber without having to specify the type argument. Now, the first thing that we're going to need is a controller. This can be private. This is an abort controller, new abort controller. And from it, we will extract a signal, abort signal, equals this dot controller dot signal. The next thing we're going to need is some kind of a type to represent the status, like fiber status. And this type should represent all the possible states of this fiber. So let's comment this out and create this type. It'll be a fiber status, and this should be generic over the success type. And the first state is going to be untouched. So that's when the work that the fiber represents hasn't been started. The next is going to be pending. So that's when the work is in progress. And the result of that work should be represented with a promise. And this promise should evaluate to the result of A, which we can auto import of A. And let me go ahead and add TS. Now down here, we're also going to want a function with which we can resolve this promise. And this returns void. So when the work of this fiber is finished, we'll call resolve with the given result value. Next, we're going to have the resolve state, which will contain the result A. And then we're going to have another state, which will represent when the parent aborted. So within a child fiber, if the parent fiber failed, then it should fail, because at that point it's an orphan, and even if it succeeds, its value isn't going to go anywhere. So maybe the only other thing we could add is parent is fiber. I don't know if this status is particularly useful, but we'll leave it in for now. So we can go back down here, uncomment this, pass in that type argument, and it'll start out as untouched. Within any given fiber, we're going to need a reference to provided requirements. So that's the fiber context. We'll say read-only CTX is fiber context. And in a moment, we're going to create a constructor in fiber, and we'll initialize this there. But for now, of course, we're going to see no initialize or diagnostic. And same thing for source, which is going to be an iterable type where the item, or in most cases, the yield, is going to be an instruction, which we will auto import. And then finally, return type is. So let's go ahead and initialize these values in a constructor. Constructor. And in here, you have the fiber context provided. We have the source, which is again iterable of instruction A. And then optionally, maybe we specify the parent fiber. Let's destructure these. And now we'll initialize these two. So this.ctx equals, and in the case that there is parent provided, we're actually going to want to grab the context from the parent as well, because the requirements that have been passed to the parent should be accessible to the child. So we'll say new map, and here we give it entries, which are the parent, if it exists, context.entries. If it doesn't exist, then an empty array is fine. And then whatever the context entries. For source, we're just going to say source equals source. And finally, in the case that there is a parent, we're going to want to attach an event listener. So if the parent aborts, then we will check if this.status, so if the current fiber status is pending, let me scroll up a little bit, then this.status equals, and the tag in this case should be parent aborted, and we'll give it a reference to the parent. And finally, this.controller.abort. So that'll communicate to any of the promise instructions in this fiber that the work can stop. Now note, what we've done so far is we set up the fiber, but we're not actually executing any of its work. So let's do that. Down here, we'll create a resolve method. This will give us the promise of result A. And we're going to want to get from this a few things. First, the status, and next, the source. I'm going to scroll down again. And then here we will switch the status tag. And in the case that it's pending, we can just return status.promise. In the case that it's resolved, we will return promise.resolved because the type expects a promise. And here we're going to give it the status result. And in the case of parent aborted, we can return a promise.resolve with null. And notice how I added a non-null assertion to null. This is a handy trick if you ever need a value that is typed as never. So in this case, it's our way of tricking the checker into thinking that we've given it the value that we specified here. And this is fine because if the parent aborted, then we never actually make use of the result. So we don't particularly care. Plus, the error is propagated from the parent. So it's not like we need to communicate any exception that was encountered within this fiber. So we've just dealt with all of the cases in which we don't want to do any additional work. But what about the case in which we do actually want to initialize the work of this fiber? Well, the first thing we should do is initialize this.status. So in this case, tag should be pending, and we're going to need to give it a promise and the resolver. So we'll say const, and we'll destructure this momentarily, promise dot with resolvers with result of A, and then here we'll get the promise and the result. Note, we don't need reject because we're not actually using the reject method. In the case of a failure, we're just going to return a result with the exception. So we're always resolving. Down here, we'll give it the promise and the resolve, but there's kind of one other piece of actually resolving within the fiber beyond just setting the result. So let's create a function set terminal status, which should take in the result, and it should set status equal to resolved with the result. It should trigger the abort method on the controller. And finally, it can call resolve with the result. So we just set up our means of resolving the fiber. Let's start looping. We're going to go down here and say iterator equals source symbol.iterator and call it. And this is going to give us our iterator that we consume to progress the fiber. Now, as we do this looping, we're going to want to keep track of our next varg, so the value that we're passing in the next method of the iterator. And initially, this is undefined, but the type is actually unknown. So we'll say let next arg is unknown. And since it's unknown, which covers undefined, we don't see an initialization error. Let's scroll a little bit. And then let's get the first instruction. So iterator.next. And this go around, we don't need to pass next arg because it's undefined, but in future calls of next, we will in fact pass the next arg. And so now we're going to say while not current.done. So as long as we're encountering yields, not the return value, we can grab the instruction from the current.value. And this is our instruction type. Now we need to handle the various kinds of instructions. So we will switch instruction.tag. And the first instruction we'll handle is promise. So in the case of promise, we're going to want to try and then instruction.f. And we need to pass in the abort signal from the fiber, this dot signal. Now, this is a promise, so we're going to want to await its resolution, and that actually gives us the next arg. And in the case that it throws an exception, we're going to set terminal status with a tag of fail and give it the exception. And we're getting this error because we're not inside of an async block. So to solve that, let's wrap this entire while loop. The other thing we need to do now that we've handled the promise case is break. Now let's handle the case of a require instruction. And this one is by far the easiest. In this case, we want to set the next arg equal to this.ctx.get with the given instruction tag. And then we break. So we're just grabbing the value corresponding to the given tag from the context of the fiber. Next, we're going to handle the case of forking or creating child fibers. So we'll say case fork, and here we'll create a new fiber. So new fiber, we'll give it parent of this, and the source is going to be the instruction.Toyffect. Now note, we're getting an issue because Toyffect is not iterable, and our fibers expect for the source to be iterable. So let's go back to our Toyffect definition. And up here, we're going to have to extend iterable with instruction.require of R, because we want to communicate the Toyffect's requirements, and then the successful value. And now let's go back to the fiber, and we're getting a different error, and that's just because we have yet to provide context. And the context should be a new map. And if we come back here, we see we're now getting a different error, and that's because we have yet to specify the context. And the context is a new map created from the entries in the Toyffects provided. Now, in the case of forking, we're actually going to just return the fiber. So next arg is going to be equal to fiber, but we do want to kick off the fiber execution immediately, and then we break. And now we're going to handle the case of gen, which is going to be kind of similar to fork, except that we're going to await the resolution and it might have bearings on the result of the parent. So const fiber equals new fiber. Very similar to above, parent is this, source is instruction.f. So we're going to call the generator function to get the generator, and that's going to serve as the source for the fiber. And then we pass in the context as this.ctx. So when we yield a Toyffect, the resulting fiber should inherit the context of the parent fiber. Now we're going to immediately await the fiber's resolution. And if resolved.tag is succeeded, then the next arg is going to be equal to the resolved value. Otherwise, we're going to set terminal status equal to resolved, which we know will be failure. And this is how we're going to propagate the error up to ancestor fibers. And then finally, we break. So we've just handled all of possible instructions. And now outside of the switch statement, we can say iterator.next. And here we are going to want to pass in the next arg. And we're going to set current equal to it. Now, something important to note is this could throw. So we'll wrap this in a try catch. And in the case that there is an exception thrown, we're going to set terminal status with a tag of fail and the exception. One other thing we should do is call the iterator's return method, which might not be present, so we'll call it like so. Wonder, do we even need this? No. And this cleanup method could also throw. So we'll wrap this in a try catch as well. But in this case, we're never making use of it. So this will fail silently, as it should. All right, so at this point, it should loop all the way through the iterator. We've only handled the iterator's yields, or the instructions. We haven't yet handled the done value of the iterator, so let's do that. We're going to do this outside of the while loop. So if we destructure value from current, it represents A. So it doesn't represent an instruction. And then we can set terminal status with a tag of succeeded and the value. And then the very last thing that we do is, of course, return the promise. Okay, so we just implemented our representation of the work underlying any given Toyffect. The next thing that we're going to want to do is create various higher level factories for Toyffects. So one such factory, and maybe we'll go to the very top of this file to implement it, is our fork function. And this is going to take in a Toyffect, so it'll have an A, it'll have an R, which extends tag, and it'll take in Toyffect, which is a Toyffect of AR. And it should give us a Toyffect that resolves to a fiber of A and has a requirement of R. And so we're going to need to have some kind of a internal factory for Toyffects. I think we should call this make. And within here, we're going to give it the given instruction, fork and Toyffect. And now we're going to need to implement make. Why don't we get rid of this type modifier and we'll import make from Toyffect. So let's go here, and down here, we will export const make equals a r extends context.tag. This will take in an instruction, and it'll give us a Toyffect of AR. Now, any given Toyffect is going to have the properties that we declared above. So first, we'll say symbol.iterator, and this can just return yield instruction. And we'll say as never, the raw yield isn't typed we don't really have great type level machinery around raw yields, so the checker doesn't really know what we're doing. Next, we're going to need to track the provided requirements. So provided, and for this, let's actually update the parameters. We'll add a provided parameter, which will be an array, context.tag, unknown, and we'll default it to empty. So this way we'll be able to call make without specifying any provided, in the case that nothing is yet provided. Down here, we're going to have our provide function. This is going to take in tag and instance, and it's going to give us a new effect. So we can just call make within itself, give it the same instruction, and then we will spread what has already been provided. And then the new entry, tag instance. And last but not least, we're going to implement run. And here we create a new fiber. So new fiber. We'll give it a context of new map with the provided. And we'll give it the source of this, because this implements simple iterator. So this is an iterable, and then we can just return fiber.resolve. And just like that, we have our runtime factory for Toyffect. Let's go back to fiber. And now we see no type errors. Let's go back to the Toyffect file, and let's use make for a few of the basic factories. First, export const promise equals, and f takes in an abort signal, and it returns a promise of a, and it gives us a Toyffect of a. So make, and here we want to be explicit about the types, so a and never. And the instruction is a promise instruction, and then we give it f. Maybe one thing that we might want to do is change the signature just a little bit. So we'll have this be, I don't know, t extends promise of any, and here this will return t, and here this will be awaited of t, and then we can say awaited t. And this is a little more semantically correct because we're using await when we actually call f. And so this ensures that we correctly handle cases where we have like promise a thing, because the unwrapping isn't going to happen automatically within the type system, but it will happen automatically runtime. So yeah, we got that covered. Next, let's create our Toyffect.gen. So export const gen equals, so in this case, y extends instruction and then the a value and our generator function. So f gives us a generator of y a, scroll little. And then the return type is going to be a Toyffect of t. And then in this second parameter position, we want to represent any of the requirements. So extract from y, instruction.require, and then we want tag because that's the constructor name. And then we can say make with a tag of gen and f. Oh, and it looks like I meant to write a there. Let's go to the index and export star as context from context, export star as fiber from fiber, export star as Toyffect from Toyffect, and export star as instruction from instruction. And now let's go over to main. We'll import from Toyffect. We're going to import context and Toyffect. We come back to this example, and let's create a rand context tag. And we're going to give it the rand constructor. We're going to give it a runtime value momentarily. We'll finish this up. And next is going to be a Toyffect of type number. Now let's actually create a Toyffect. So Toyffect.gen, and here we provide a generator function. And let's try some of our factories. So maybe first we'll say const a equals yield and toyffect.promise. Here we'll say promise.resolve 42, and the type of A is number. Let's log it out, and then let's get our dependency. So dep equals yield rand. This should give us that value that we described. So in this case, the value is an object that contains Toyffect under the key next. And so we could say b equals yield dep dot next, and this should give us a number. Maybe let's log these out as well. And separate them. And we'll take a look at the signature. We hover over and we see our Toyffect has no return type, and it has the requirement of rand. If right here we were to return a string and then hover over Toyffect again, you see now it has an A value of string. In the way that we've structured Toyffects, we don't use piping in order to provide the requirements. We call this provide method. So here we'll give it the rand tag, and then it expects the instance. So in this case, instance is an object containing next. Here we'll say toyffect.promise, and I guess we'll promise resolve math.random. And now if we were to hover over Toyffect again, the requirements are never, because we provided it. So let's clean this up just a little bit. And now let's run it. Over here, we can await, and then we get back the result with the A. One thing we should see if we don't provide all the requirements is a type error. This context of Toyffect string rand is not assignable to methods this of Toyffect string never. Rand is not assignable to type never. So we have the type safe dependency injection. Let's put this back, and we will console log Toyffect, although I suppose now this is just the result. And first I'm going to run build so that this example actually has the build Toyffect package. And next we will execute the example. So first it logged out A. Next it logged out the Toyffect. Next it logged out the dependency. So an object containing this next Toyffect. Then it actually used the next Toyffect. Then it actually used the result of yielding the next Toyffect. So log that out. And finally, we see the success. If in here we were to say throw new error by, and then execute this, we see we still get a result. The tag is fail, and then it has the error keyed as exception. But we're going to get rid of this. And there's one more feature I'd like us to implement, and that's a really naive parallelism. So we'll go back to Toyffect, and we're going to implement all. So this is going to accept a list of Toyffects, any Toyffect. So Toyffects L. So in here, we're going to have a map type where we map over key of L and Toyffect.a. So we want to extract the successful result of the current Toyffect, which is LK. And next, we're going to want a union of all the requirements of the Toyffects contained in the list. So for this, we can say Toyffect.r. And in here, we just extract Toyffects. And then we can do something interesting. We can use gen, iterate over all of the Toyffects, and within here, we're going to create a new fiber for each Toyffect. So we're going to want to keep track of these fibers. Let's say const fiber equals array of, and here we'll reference fiber, but actually, since we're going to need fiber fork, let's go up to the top and let's do this as a namespace import, which means that down here, we're going to need to say fiber.fiber. We'll do fiber.fiber. Oh, this is fibers. And this is an empty array to begin with. And for every Toyffect, we're going to push a new fiber, which we'll create by yielding fiber.fork with the given Toyffect. We're going to want a list of the resolutions. So we'll say fibers.map and then fiber.resolve. And to do this a little more cleanly, we could say promise.all, and then this is actually just resolution, so just the list. But we don't actually want to kick this off here. We want to let the fiber interpret. So we need this to be a promise, so in Toyffect form, and we can return yield it. Now the checker doesn't really know how to work with these map types. So once again, we're going to need to override it. And with that, we should be able to go back to our example. So, and let's say const c equals yield Toyffect.all. And here we'll give it an array where we have the Toyffect.promise, promise.resolve, A. And then we'll do the same thing with B. And then let's console log C. So now let's run another build. We'll run the example again. Oh, and it looks like we're actually getting the entire result when that's not what we wanted. So let's fix that. We'll go back into all. Right here, maybe we'll add some braces. We'll say const result equals wait, add async. Then if result.tag is failed, then we will rethrow the exception. Otherwise, we will return the value. All right, let's go back to the example. We will rebuild and we will run it again. And this go around, we see A and B, just as expected. Maybe just for the fun of it, let's create one more dependency. This will be a logger, and this will have a log function, which takes in a message and returns void. Down here, we can say const logger equals yield logger. And now we're getting an error again because we haven't provided that requirement. So maybe below here, provide logger log message, and this will just console.log message. Now up here we can say logger.log greetings from Toyffect. And let's run it. We get the greeting. And if we were to comment out the provides and run, as well as delete this unnecessary wait, we now see the additional dependency represented in the requirements union. So that covers it for today. Thank you for watching. See you next time.